All right, guys, and welcome to our second to last chapter. So we're going to start today with something called sequences, and this is really a setup for the rest of the chapter. But let's talk about what a sequence is. So a sequence is a list of numbers that follows a rule. And there are many different steps and sequences that this might take, but generally when you hear this phrase a sequence, it's a list of numbers following some kind of mathematical rule. So when we write a sequence, we're usually going to write these with squigglies. So usually written in kind of like squigglies like this. So for example, you might see the sequence that just goes up by 1 every time. So 4, 5, 6, 7, 8, and so forth. This is a sequence. And because this is calculus, we're not just looking at a sequence of 4 numbers or 5 numbers. We're looking at a sequence of infinite numbers most of the time. You might see something where they get smaller. So maybe 1, and then 1/2, and then 1/3, and then 1/4, and 1/5, and so on. You might see something where it's just like the powers of 3. So 1, 3, 9, 81, so forth. You might see something where they alternated. So where it was like a negative and then positive. So negative 1/2 and then 1/4 and then negative 1/8 and then 1/16 and so forth. You might see like a super boring sequence that every number was just a 4. Well, it's obviously pretty straightforward in terms of analyzing. You might like kind of bounce back and forth. So -2 and then 5 and then -2 and then 5. You may have even heard of the famous Fibonacci sequence. The Fibonacci sequence, remember, where each number is the sum of the 2 numbers before it. So if you just take any 2 numbers and add them, you'll get the next term. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and so forth. So sometimes we'll see sequences written like that, and sometimes we'll see them written like this, where they have an equation. And the equation looks like this. So you'll say a sub n is equal to, and that's in quotes, n squared plus 1 over 2n squared. And what this notation represents is if you see like this a sub 3 just means like the third term. It is the term when n is equal to 3. So each of these, this is like a term of the series. Each individual number is one term. And the sequence is just a collection of each of those terms. So if you look at like, say the first 3 terms, the first 3 terms of the series would be a sub 1, a sub 2, and a sub 3. And if you want to find a sub 1, it's kind of like an f of n, and you just plug in n equals 1. So this is just where you just plug in n equals 1. So if you just plug in n equals 1, you just get 1 squared plus 1 over 2 times 1 squared, which is 2 over 2, which is 1. If you want the next term of the sequence, you'd plug in 2. So a sub 2 would be 2 squared plus 1 over 2 times 2 squared, so that would be 5/8. If you wanted a sub 3, again, you just replace all the n's with 3, so you plug that in. So you have 3 squared plus 1 over 2 times 3 squared, so that's 10/18. Okay, and if you wanted, of course, the 30th term, a sub 30 would be 30 squared plus 1 over 2 times 30 squared, which is 901 over 1800, but the actual value there doesn't matter. It's just showing that you can get any term by just kind of plugging in that number. Okay, here's another fun example. Let's suppose we have to write, the first 4 terms of this sequence. Let's say a sub n is equal to -1 to the n divided by n factorial. Okay. And when I say the first 4 terms, usually we're going to start at n equals 1. So this isn't comp sci, so this is a sub 1, a sub 2, a sub 3, and a sub 4. Okay. Now, I want to remind you of what the factorial does. Remember, factorial is basically taking every number and multiplying that down to 1. So 4 times 3 times 2 times 1, which is 24 in this case. By definition, 3 factorial is 3 times 2 times 1. By definition, 0 factorial is actually defined as 1, which seems a little weird. We'll talk about that more later, but trust me, it makes sense for now. But just in general, factorials are big. And I mean like really big. So for example, like 70 factorial might not seem like a very large number, but 70 factorial is actually bigger than the number of individual atoms in the entire universe, which is obviously an astonishingly large number. So that just shows, 70 factorial is that big, consider 100 or 1,000,000 factorial. The point is factorials are very large. So anyway, so a sub 1, so that's saying plug in n equals 1. So that's -1 to the first power over 1 factorial. So that's negative 1 over 1, which is negative 1. A sub 2, so that's negative 1 to the second power over 2 factorial. So that's 1, 2 factorial is just 2 times 1, so that's 1 over 2. A sub 3 is negative 1 to the third power over 3 factorial. 3 times 2 times 1 is 6. And that's negative 1 times negative 1 times negative 1, so that's a negative 1. Okay. And then a sub 4 is negative 1 to the 4 power of 4 factorial. 4 times 3 times 2 times 1 is 1 over 24. So that's what's going on there. And you might kind of be wondering, a question that we'll talk about is what does the negative 1 to the n do? And you might have been looking at this and just said, oh, all it does is it makes the terms alternate. That's it. Okay, so that's kind of what's going on in the first couple terms of sequence. One other thing that we're going to do is we're going to talk about kind of a recursive sequence. And you'll see these sometimes. These are kind of cool. A recursive sequence looks like this. And it says, for example, say a sub n is equal to 2 times a sub n minus 1 plus 1. And they'll also tell you, say, a sub 1 is equal to 1, and ask you to find, I don't know, like a sub 2, a sub 3, a sub 4. Okay. So basically what this is saying, and this is kind of weird, it's saying the nth term of the sequence is based on the n minus 1th term. So each term is based on the term before. So when you want to find a sub 2, so this is saying, the nth term of the sequence is this equation. When you find a sub 2, you replace the n's with 2's. So you replace this n with a 2 as well. So a sub 2 is just 2 times a sub 2 minus 1 plus 1, which is just 2 times a sub 1 plus 1. So it's basically like saying, f of n is equal to 2 times f of n minus 1 plus 1. Like that's basically what's going on there. Okay, so they're always going to give you some base case, some initial value on these, so you'll plug that in. So in this case, it's just like 2 times 1 plus 1, which is 3. And then if we want to find a sub 3, so it's saying, now you plug in the n equals 3, so that's 2 times a sub 3 minus 1 plus 1. So that's 2 times a sub 2 plus 1, and we just found a sub 2. So that would be 2 times 3 plus 1, which is 7. And of course, plug in the same thing. A sub 4 is 2 times a sub 3 plus 1, which is 2 times 7 plus 1, which, I don't know, like I'm pretty sure that's 15. Anyway, so that's a recursive sequence. And a recursive sequence is kind of what's going on where like each term is defined by the one in front of it, or the term before. So we're not going to deal a ton with recursive sequences, but we will see them occasionally. Okay, so anyway, that's just an introduction to sequences, how to like use the notation, how to get the first couple terms. Let's get the calculus question. Here's our big question. Okay, and the big question is do the terms approach a certain value as n gets bigger? And of course, this is calculus, so when we get bigger, eventually we're saying n goes to infinity and think about that as a limit. But let's look at like the examples from above. If we take a look at this first example, like, yeah, they're not really approaching anything, right? Those numbers get bigger and bigger and bigger. And same thing with this one. But in the second example right here, we can kind of see those terms are actually getting closer to 0. You get a 1/10 and a 20th and a 100th and a millionth. And those get smaller and smaller and smaller. Same thing with these. These go to 0. If we look at this one, these terms approach 4 because they're always 4. And these don't approach anything because they just keep alternating back and forth and back and forth. So there's different behavior for what's happening as n keeps getting bigger. Like, do they approach a certain value like these going to 0? Or do they just keep getting bigger and bigger? Okay, so keeping that in mind, let's use some vocabulary here. So we're going to say a sequence, and these words should look pretty familiar, but a sequence is convergent, or converges, if the limit as n goes to infinity of a sub n, so the limit of each individual term, if that limit exists. So basically what that's telling you is the terms approach a real number. So as n goes to infinity, the terms approach a real number, and that's convergent. Now on the other side, we will say a sequence is divergent, or the sequence diverges, if Shailene Woodley's in your movie. And if you take that limit as n goes to infinity of a sub n, if that limit does not exist, or is plus or minus infinity. So that's what you're basically saying. If you have an equation, you just take a limit as to what's going on there. Okay, so basically, let's say this. Let's suppose we have the sequence a sub n is equal to 1 over n. And I will just ask this kind of on all these, is the sequence convergent or divergent? And all you really need to do on these problems for a sequence is just take a limit, which is pretty straightforward here. So we're just going to take a limit. Okay, so if we take the limit as n goes to infinity of 1 over n, you get 1 over infinity, which is 0. So all that's telling you, all that means is that the terms approach 0. Now, that's not the answer, right? Our answer is that it converges because 0 is a number. But the terms, but the terms approach 0. That's what this means, is that n gets bigger and bigger. The terms of this sequence just go closer and closer to 0. And that's all we're asking, is basically, that's what this question is saying, is what happens to the value of the terms as n goes to infinity. That's the question that we're asking on these types of problems. Okay, so let's look at a few more. Let's suppose we have, the sequence, let's say b sub n equals 3 to the n. Well, here we're going to take the limit. So if we take a limit n goes to infinity of 3 to the n, well, obviously that's 3 to the infinity. That's infinity. Infinity, as you know, is not a real number, so this diverges, which makes sense, right? Because if we take a look at the terms of this is 3, 9, 27, 81, 243, like those are just getting bigger and bigger and bigger. And they're not approaching a real value. So this one diverges here, which I've really done a poor job of writing. Sorry about that. Okay, so let's look at kind of two more examples like this. And again, same question, do these sequences converge or diverge? So let's say we have 5n cubed over 2 minus n cubed. What's that, you say? A fraction? Okay, well, let's take a look at the top and the bottom because something magical might happen here. If we take the limit n goes to infinity of 5n cubed, that's infinity. If we take the bottom, we take the limit n goes to infinity of 2 minus n cubed, that's negative infinity. So because you got an infinity on top and bottom, we want to use L'Hopital's rule. So this is the same as just taking, let's say, the limit of the top and the bottom. So the derivative on top is 15n squared, bottom is negative 3n squared. So those cancel, so this just turns out to be negative 5. So again, what that means is, as n goes to infinity, the terms of this sequence approach negative 5. And you can try this in your calculator, right? If you plug in 100, 1,000, a million into these equations, you're going to get a decimal that's closer and closer to negative 5, the larger value you put in. So that's what's going on there. Just one more example using L'Hopital's. Suppose we have, d sub n is equal to the natural log of 2n squared minus n over n squared plus 3. I'm going to clean that up because that's hard to read. 2n squared minus n. Okay, so again, we have in this case, we're trying to see if it converges or diverges, so we just take a limit as n goes to infinity of this. So 2n squared minus n over n squared plus 3. Okay, now what you can see is we're going to kind of specifically look on the inside. If we look at the top, we take the limit there of 2n squared minus n, and we look at the bottom. Okay, now the bottom was we take the limit n goes to infinity. We can see that's obviously going to be infinity. On this case, like infinity squared is way, way, way bigger than just regular infinity, obviously, so this one's going to infinity as well. So what you're doing is you're kind of doing L'Hopital inside the log. So what that means is this is just going to be the limit as n goes to infinity of ln of, let's see, that's 4n minus 1 over 2n. You can use L'Hopital's again. Some of you guys may have also just said, hey, they're polynomials. We can just look at leading term over leading term. So this is just the ln of 4 over 2, or the natural log of 2. So again, what that means is it converges, and the terms approach ln 2. So the larger values that you plug in, you just get closer and closer to ln of 2. Okay, so that's the sequence. We're just looking at the terms today. We're not doing anything with them. We're not adding and multiplying them, anything. We're just saying, as n goes to infinity, what do they approach? Okay, hope this helped. This should set you up nicely for the next video. Make sure you bring me some questions in class. Thanks for watching.